Okay, good morning, gents. Today we're going to have a look at interpenetration and development, or also referred to as pierced solids. Okay, right, so very similar to your solid geometry. The number one rule that you have to remember, when working with interpenetration as well as solid geometry is to number. If you don't number, you're going to make life very difficult for yourself. Okay, then there's 3 steps that we have to follow if we want to be successful with our interpenetration. The first one is height. The second one is placing. And then the third one is referred to as TPs, and that is your turning points. Right, okay, so let's quickly start with our number one rule. Let's start with our numbering. I'm going to start with my top view. I'll start with 1, 2, 3, 4, 5, and 6. Due to the fact that it's a hexagonal prism, I'm going to do it on my front view as well. So it's number 1 and 1, number 2 and 6, 2 and 6, 3 and 5, 3 and 5, as well as 4 and 4. Now I have a square hole running straight through it. It's 4 corners, so I'm going to start just to bring some differential numbers in: A, B, C, and D, just to bring something else to the table. Right, so I've numbered on my top view, I've numbered on my front view. Now I have to do it on my right view as well. How do I know this is my right view? Due to the fact that we're working in first angle orthographic projection, everything is the other way around. So I've got my top view at the bottom, then I'll have my right view on the left hand side. Okay, so I'm going to start with the numbering. I'm going to follow, this will be 2 and 3, 2 and 3. This will be 1 and 4, 1 and 4, and then the last one will be 5 and 6, 5 and 6, 5 and 6. Okay, so now my numbering is finished, so now I can continue with my 3 steps. Okay, so first step will be height. Okay, how am I going to determine the height? So what is the height all about? I basically want to know where on my left view will my penetration points A, B, C, and D be situated. Okay, so I'm going to determine that. I'm going to start with the height. Okay, so I'm going to project over A, B, C, and D to my left view, or to my right view, so I can determine my penetration points. I'll start off with A. Now you will see that A and C is on the exact same height, so I won't be needing C's height. I'll do number B, and then I'll do number D. So I've got A, B, C, and D heights projected over. Thus, in short, what does this information provide me with? Now I know somewhere on this height line, penetration point B will be. Somewhere on this height line over here, A and C will penetrate, and somewhere on this line, D will penetrate. Okay, so now I'm finished with the height. Now I can continue with the placing. Now to do that, what I'm going to do is I'm going to start with 1 point, which will be number A, and then we'll do B, C, and D afterwards, but we'll start with A. Okay, to do that, what I'm going to do is I'm going to project A downwards to my top view, because then I'll be able to see exactly where on my hexagonal prism point A penetrates and exits, and then I'll be able to project it over to my right view, and then I'll be able to get my placing point. Okay, so I'll start with A. I'm going to project A down to my top view. Now by doing that, now I can see my penetration point A and my exit point, which is A as well. Okay, because remember, this is my front view, this is my top view, so I'll be seeing my front from this side. Okay, so it's my penetration point and that's my exit point. Okay, now I've got my 2 points. Now I'm going to project it over to my right view. Start with my penetration point. I'm projecting over my penetration point to my 45-degree line. And there it makes contact with my 45-degree line. I'm going to project it upwards to my right view. Okay, now this is the very simple part. Okay, I'm going to follow A to the vertical line and then A to the horizontal line, and there where they cross. So it's A's vertical, A's horizontal, and there where they cross, that will be point A. Right, so that's the penetration point of A. Right, now I'm going to do the exit point of A, which is this one over here. I'm going to project that one over and upwards to my right view again. So I'm projecting it over to my 45-degree line, and there it makes contact with my 45-degree line. I'm going to project it 90 degrees upwards. So this point, once again, the vertical exit point of A, and the height of A where they cross, that will be my exit A. Right. Now, gents, just a quick piece of information. Interpenetration is basically when something penetrates something else. Okay, it doesn't go straight through, it only penetrates it. Whereas a pierced piece is where it starts in the front, it goes straight through, and it exits at the back. Just to make it real simple for you, just think of someone that gets his ears pierced. It goes into the front and it exits at the back. So the pierced piece is straight through, and penetration is only penetrating without exiting at the back. Okay, so this is how I determined point A's placing. Now I'm going to do B, C, and D's placing and exit points as well. So bear with me, I'm quickly going to do that. Penetration point B as well as D, and exit point B as well as D. Penetration point C, exit point C. Okay, now I'm going to follow the exact same steps as I did with number A. I'm going to project my points over, and now you will see that A and C is on the exact same line. So it's good, just one lay still, it will really help a lot. Okay, right, so now I'm going to follow it once again. Now I'm going to start with B. B's vertical line and B's height line where they cross, so the vertical and horizontal where they cross, that will be point B, and the same on this side. Okay, so B vertical and B horizontal, that will be my new point B. Now C's penetration point and C's height line. So now you will also see that A and C is on the exact same point, and the same with the other C, the exit point. If I follow that one, vertical and horizontal A and C will be on that point. Okay, now I'm going to go over to D. D's vertical, D's horizontal across each other there, so that will be D, and then the exact same with the exit point, so this will be my point D. By doing this, I've determined the penetration point of A, B, C, and D. Exit point of A, B, C, and D. Right, so now I'm finished with the placing. Now I still have to do my turning points. Now, this is something new. So what is a turning point exactly? Remember, if I see it from the front, this is my front view. If I see it from the front, remember this is my top view. Okay, so seeing it from the front, this plane over here, plane 5 and 6, lays flat in front of you, right? But plane 5 and 4 and plane 6 and 1 lays at an angle. Okay, so it changes direction. Okay, so turning point is wherever a plane turns and changes direction. Now, if I refer to my front view now, this plane is flat, but this plane over here goes backwards, and the same with this one, so it turns. So this point over here is my turning point. Okay, this point here is my turning point. This point here is a turning point, and this point over here is a turning point, right? Okay, so I'm going to refer to them as TP1. This point here will be TP2. This point here will be TP3, and this point here will be TP4. Right, so now I've identified my turning points. Now I have to get my turning points on my right view. Okay, how am I going to do that? Once again, I'm going to project it over to my right view. I'm going to project them over to my right view. Start with TP1. Now you will see that TP1 and TP2 is on the exact same height. And TP3 and TP4, you will see the exact same will happen there. TP3 and TP4 is on the exact same height. Right. Now, where do I get TP1? TP1 is on corner number 6. Why? Because the penetration point is, we're going to start with the penetration first. The penetration corner is on 6. Okay, so this one will be on 6. Right, so now I'm going to go over to corner 6, bring it over horizontal, the horizontal line. Okay, I know it is on corner 6, so this point here where they cross will be TP1. I'm going to show it again. This TP1, okay, is on corner 6. Okay, it is on this whole corner here is corner 6. So on corner 6 it changes direction. So I'm projecting it over to corner 6, which is on this corner here, and there where they cross, that will be TP1. Everybody with? Right. Okay, now I'm going to go over to TP2. TP2 is on corner number 5. Okay, so it's on corner number 5 over here. Finish with this one. Okay, where's corner 5? Corner 5 is in the same line of sight as corner 6. Okay, so I'm projecting this one over. So this will be TP1 as well as TP2. Right, now I'm going to go over to TP3. I'm projecting, it's on corner number 5 once again. So I'm working with corner number 5. Okay, so I'm projecting it over to corner number 5. So this point here will be TP3. Okay, now I'm going to go over to TP4. Now once again, TP4 lays on corner number 6, which is in line with corner number 5. Okay, so this will be then TP3 as well as TP4. Okay, so now I've determined TP1 and 2, TP3 and 4. Okay, finish with the penetration. Now I have to work on the exit. Now with the exit, we're going to work on TP1 on corner number 2 because it exits on corner number 2. Okay, so I'm going to circle it so you know which ones we're going to work with now. So TP1 will be on corner 2 and 2. Okay, so I'm projecting it over. So this will once again be TP1. Okay, now TP2 with the exit is on corner 3. That's why I'm going to circle it once again. Okay, so TP2 is on corner 3. So it will be TP1 and TP2. Now I'm going to go over to TP3. Once again, it's on corner number 3. So I'm projecting it over. So now this will be TP3. And then by doing number 4, it's on corner 2 once again. So this will be TP4 as well. Now I'm finished with all my turning points. I can continue. Now this is the part where you have to really concentrate. Okay, I'm going to start with the penetration points on this side. So I'm going to start with this part here. Right, so A goes to TP1. So A travels to TP1. So A to TP1. Going to connect them. A to TP1. TP1 then travels to B. So TP1 goes to B. Okay, B then once again goes to TP2. So B basically travels back on the exact same line to TP2 because TP1 and TP2 is on the exact same point. TP2 goes to C. So it goes back to C. Right. So from C it goes to TP3. So C goes to TP3. So now I'm going to connect these two. So C goes to TP3. Come down there. Okay. TP3 then moves to point D, which is here at the bottom. So I'm going to connect them. D then goes to TP4. So D back to TP4, and then TP4 returns to A. So TP4 to A. So this is what it will look like if there was a hole, a square hole going through my hexagonal prism. Now I've done the interpenetration. Now I have to do the exit, the piercing part. Right, so I'm going to follow the exact same steps. A to TP1, TP1 to B, B to TP2, TP2 to C, C TP3, TP3 to D, D to TP4, TP4 to A. Usually when I make a reference to this, I usually refer to when you were younger, your mother used to buy you a coloring book, or not everyone, but yeah, in some of the coloring books, there was this picture that you have to connect all the dots, and when you finish with all the dots connected in the numerical order, you will get a picture, and then the picture is created by connecting all the dots, and then you can only after that do the coloring part. Right, so now I've determined all my points. Now I just have to connect all my lines again so I can complete my drawing. This pencil is going to break once more. I'm going to lose myself. As you can see, there's nothing more than a simple hexagonal prism that we drew in solid geometry. The only difference is now that there's a piercing running straight through it in the shape of a square prism. Okay, and then the last line that will be visible is this corner over here. So this is what your drawing will look like if there's a square hole piercing a hexagonal prism and running straight through it, front view, top view, and right view. Gents, if there's any problems or any questions, you're welcome to contact me or Mr. Yanni or Mr. Meyer, and we'll gladly assist you with any problems.